Now, I do want to spend a few minutes looking on a flat, as we call it, transmission line. And this is the case where my load, ZL, just happens to be equal to Z naught. In a lot of cases, this is actually a highly desired result, and we will call it a matched transmission line. Or less times, we'll call it flat transmission lines. You will see this is a result out of the graphs that we will see in a second. But nevertheless, let's look at what happens when ZL is equal to Z naught. So when my ZL is equal to Z naught, basically my gamma L, which is ZL minus Z naught over ZL plus Z naught, will basically equal to 0. This is fantastic because it means that the reflected power will be equal to 0, and the power that the load will consume will be equal to the incident power. So no reflected power. Many times that's the desired result, particularly when we build a line to connect the source to a load and we want the power to balance well. The VSWR, which is 1 plus gamma L over 1 minus gamma L, is going to be 1, which, as we discussed before, this is the minimum value that you plan to get. Now, the V of Z is having now only the incident wave, so it's V naught plus e to the negative j beta z, while the IZ is also very simple, is V naught plus divided by Z naught e to the negative j beta z. There is no reflected wave here, so both are very, very nice. And of course, if you divide V by I rather, you will basically able to get the fact that the ZL is equal to Z naught along the entire transmission line length. So this is the simplest possible case, in other words. It's also the most boring case, and that's why I'm presenting it here at the end, in the sense that everything looks nice, everything is simple. You have a constant voltage. There's no maximum or minimum, hence the name flat line. And that's true both for the voltage as well as for the current, as you will see here. So this is the case of the matched transmission line. That means, once again, that the load has the same value as the characteristic impedance of the line, and you have essentially the simplest possible scenario.